Hello everyone. Today we'll be doing sound part 3 and we'll be learning the basic characteristics of sound which are written here, the loudness, pitch and quality. These are the basic characteristics of sound that we are going to cover in this last part of sound as per the syllabus of the board exam. And you can understand, we'll start with loudness. Okay, so we'll come up with pitch and quality later on, but right now we'll start with loudness. So we'll start with loudness. Now what is loudness? Loudness you can understand. Suppose you're talking and like I am talking, if I talk loud, you will hear it louder, and when I'm talking in a lesser amplitude, when I'm whispering, that time you will hear the less amount of sound. So basically loudness depends on the amplitude of vibration. More the amplitude, more will be the loudness. I'll come up with the on what factors loudness depends and everything I'll come up. But just now we just understand what is loudness. It is the sensation by which we can understand which sound is very loud and which sound is very less, or it's a whisper or it's a loud sound that we can understand, and the characteristics we call it loudness. And loudness is it depends on the waveform definitely. If I draw two waveforms here and both of them, if they are having same type of pattern, only difference is the amplitude. You can see this amplitude and this amplitude, they are different. This is bigger one, this is larger, this is having more amplitude. So this waveform will have more loudness. This is how we categorize loudness, and we'll start, we have already started this section related to loudness, and now we'll understand on what factors loudness depends. Okay, so now we'll understand what are the factors on which the loudness actually depends. Before we go into that, we first understand what is intensity, okay? Because intensity is the main quantitative analysis of loudness. We cannot actually measure loudness, we actually measure intensity and then we measure loudness, or we give a qualitative description of loudness. So you have to understand, in physics there are certain things which are basically sensations and we cannot actually measure them. In loudness is also a kind of sensation to us. So the measurable quantity which determines the loudness is intensity. Okay, and what does intensity, or intensity is defined for any kind of wave, it is sound or light or whatever it is, even heat. The intensity, the definition is same. Please do remember this, it will be required even in the higher classes. Intensity of sound or intensity of wave is defined as the amount of energy passing per unit area normally per unit time. That means how much energy you are capable or you are transmitting through a particular area normally and per unit time, that is per second. So you can understand the intensity is denoted by the letter I, and the unit is energy, which is joule per unit area, which is meter square, and per second, and this joule per second is watt. So this is the standard unit of intensity, watt per meter square. And you can understand that intensity actually signifies the quantitative description I told you of loudness. Now what is that? Loudness is totally dependent on intensity. Okay, more intense means more loudness, and intensity actually depends on a lot of other factors, and we say that loudness finally depends on the factors on which intensity depends. Got my point? Loudness depends on the factors on which intensity of sound depends. Right? Good. So what are the factors? First of all, you can understand that it is saying the amount of energy passing per unit area per unit time, right? So more we have amplitude, more we'll have the wave energy. Because you can understand, just imagine in this fashion, later in higher classes we'll understand this analysis more better way. You see, this is a waveform of a sound. Okay, so energy which it is transmitting is basically these waves which are transmitted, the area it is covering. So more the intensity, more energy is actually getting transmitted. So we say that intensity is directly proportional to the square of amplitude. This, how it came, is not in the scope of syllabus. It's in a bit higher physics. Okay, and intensity is also dependent on inversely to the square of the distance from the source and the listener. I mean, if the source is very far, even if the sound is very loud, sorry, as a listener, I will listen to that intensity quite faint, because it is coming through a long distance. And eventually these two relations gave us some other interpretations on which the intensity or loudness of sound depends. These are given in your textbook. Go through that. I'm just giving you all the details. Write these in your classwork so that it gives you a kind of manual while we're actually studying this textbook. Okay, so intensity inversely proportional to distance, square of the distance, inversely directly proportional to the square of the amplitude. Even it is also dependent on the area of surface. More the surface, intensity will be lesser, because we are saying it is per area, per unit area. So more the area, more energy will enter. Or suppose you are sending some amount of energy, say 10 joule, but the area when it is 1 meter square, it is 10 joule per meter square. Okay, per second is understood, fine. But when you are sending again 10 joule of energy, now the area is 2 meters square, then the effective energy passing per unit area will become 5. So this analogy, I hope you can understand that more the area, less will be the intensity, because for this given amount of energy or given us for a given source, suppose I have a limit of transmitting energy through sound, because I have a particular mechanism by which I can have a minimum and maximum amount of energy that I can transfer. So eventually I have a fixed area, so I can change the intensity by giving more energy, and then the intensity will be higher and the loudness will be higher. But at the same very time, if you are sending different, if you are not sending different energy and you are changing the area, then also the intensity is affected. Alright, even it is dependent on the density of the medium through which it is passing. That is quite obvious, because you are hearing sound, so sound is dependent on the density of the medium. Even it is dependent on the nature of medium or the particle which are present in between the propagation of the sound wave. Alright, so these are the factors what we can say, and we have a clear relationship between intensity and loudness. You need not to analyze this expression. You have to just remember this in your syllabus. It is just loudness is equal to some constant K, and it is log I, which is I is intensity. Okay, we have a unit of loudness. Please understand, the unit of loudness is decibel. Bell is the concept by which we discovered the kind of how much loud sound we are hearing, and it is decibel, so 1/10 basically. So that way we actually calculate this. So what is decibel? They say that decibel is a unit of loudness. It is measured in a sense using the logarithm, of course, because you can see it's k log I. So when intensity changes by 26%, when the intensity of sound changes, remember it is a change. When intensity of sound changes by 26%, then we say the unit of the loudness is 1 decibel. Okay, so when the intensity variation is around 26%, then only that particular loudness corresponds to 1 decibel, and then we can calculate the rest of the thing. In your book you will have a list. All right, you'll see that in that list there are a lot of different sounds, decibel levels are mentioned, and then it can give you a qualitative idea how different sounds have different kind of loudness and how loud or how faint the sounds are. Okay, so I hope you have understood what loudness is, on which factors it is dependent. Remember again, I told you again, I'm telling you, intensity is the quantitative measurement of loudness. So that is we are going to calculate finally. Alright, and 26% variation in intensity will give you a loudness of 1 decibel. This is what the definition is given in the textbook. Go through that and do read the list. I'll come up with the next topic, which is the pitch. You can see in this picture of the sound levels in decibels, starting from jet at takeoff till the dropping of pin. You can see the list. Please just have a look in this particular list, which is there in your textbook. Okay, this is important. You should know this. So dear students, now we'll understand what is pitch. Actually, pitch you already know, because the very common example you'll usually see, I'm saying, that boys, okay, they have a different type of note of their voice, and girls, I mean men and women, they have different tonal quality, and that tonal quality by which you can understand, suppose you are talking to someone unknown, okay, and that person is saying hello from the other side, and by seeing the tonal quality you can guess whether that person is a male or a female, right, usually. So that way we can understand that how pitch differs. So it is a different characteristics. Unlike loudness, here we are not dealing with how loud or how grave a sound is. We are rather interested that how shrill a sound is. More the sound is shrill, more it is having pitch. Okay, and pitch, again I'm telling you, it is again a sensation. Right now whatever I told you, these are all sensations. Okay, and in science we cannot actually calculate the sensations. What we can calculate is a physical quantity which we can measure, and we can measure frequency, and based on frequency we can actually measure pitch. So we say pitch is dependent on frequency. Okay, it is completely dependent on frequency, and more the frequency, more will be the pitch. So you can understand in your book also this graph is given. So if you have a sound like this, try to understand, and if you have a sound like this, so you can easily understand this sound, this one will have more pitch because it is having more frequency. Their amplitude may be same or maybe bigger, that doesn't matter. That way the loudness will have. So now the characteristic property or the measurable quantity for pitch is frequency. So more the frequency, more will be the pitch. You can do one experiment at home right now. After you finish this class, just go to the washroom. If you have a bucket out there, make it empty first. Please don't waste water though. Okay, keep it for something else if it is filled, or if it is empty always, just place it below a tap, open the tap and just hear the sound. You'll see gradually when the water level is rising up. Okay, the way I told you regarding the other factors, I already told you air column vibration, string vibration in the last part. So from there also, when the air column is decreasing, you will see certain change in the frequency of the sound you hear. Okay, more it is getting filled, you'll hear that the frequency will definitely increase. So that is what we say. And even in our idioms we have a word that empty vessel sounds more, because it is having a large water column. Okay, so it will have a large frequency to produce, and then the pitch will be higher. So this is what we call about pitch. There is no unit of pitch, obviously. We just say it is more higher frequency, so it is having more pitch. It is having lesser frequency, so it is having lesser pitch. Okay, I hope you have understood. A picture will come up where you'll understand these waveforms and the other characteristics for this, which are given in your textbook already. After writing all this in your classwork, please go through the textbook and use your classwork as a study manual. Now I'll come up with the new concept after you see the picture, which is quality. So here is a graph which is what I already had shown on the board just now. It's showing again the two tuning fork A and B having two different frequencies of 256 Hz and 512 Hz. You can see one is double of another, and so which is having a lesser frequency is actually producing a grave sound, and which is having a higher frequency with this tuning fork B is giving a shrill sound. So that is, and also you'll find in your textbook that it's written that this case of a flute, a lower note is obtained by closing more holes so that the length of the vibrating air column increases. So, and when you decrease the air column, then also there will be another note which is having larger frequency and larger pitch. So these things you should know. Now we are aware of loudness, we are aware of pitch. Now we have the last characteristics of sound that we have to understand, which is quality. Okay, so quality necessarily defines that it is something. Quality in human depends on the intrinsic attributes of a particular human resource. Like in our class, we have a lot of students who are very naughty, we have a lot of students we are very serious, and we have also a lot of students who are naughty and serious. We also have students who are naughty and they don't study. Okay, and then we have a lot of events that goes on. Even during this session of online classes, I am managing certain naughty and intelligent and the students who are not studying. So all these are dependent on the quality, which is very much intrinsic. Similarly, quality of sound is also dependent on the factor or the source where which medium is vibrating. That is very important in order to calculate or in order to understand what quality is. Suppose I am singing, okay, fine, I am singing, and Kishore Kumar, when he is to sing, there will be a difference. I'll be singing the same song that Kishore Kumar is singing. I am a male, he is also a male, no problem. But ultimately that will happen. You will understand, okay, this is Kishore Kumar and this is Arijit Ray. So that way, so what it differs is the quality, because the nature, my trachea, my vocal cord is very much different from any other person. And in this case it was Kishore Kumar I was comparing, but it differs from everyone. Okay, we have different type of and n number of probability of different vocal cords. So we have different qualities. Even there had been lot of songs where Kishore Kumar, Lata Mangeshkar, even Asha Bhosle, they both sang the same lines. But we understand this is Lata Mangeshkar, this is Kishore Kumar. Okay, when we have almost similar credentials of quality of the timbre of the sound, then also we can distinguish. Why? Because they have different vocal cords. And what actually distinguishes, now we have to come to the quantitative analysis, and for quality the quantitative analysis is wave form. My dear students, now we have 3 different characteristics known, and we also have to list it down in your classwork. Please, I do repeat, list it down in your classwork, that on which quantitative factors are, what quantitative factors are involved in order to calculate the particular sensations. Loudness, pitch, quality, these are sensations. Measuring quantities are very important. Loudness, what it is, intensity. Pitch, what it is, frequency. Quality, what it is, waveform. Please write 2 columns: characteristics, quantitative, quantity or quantitative measurement. So loudness is intensity, pitch is frequency, and quality is waveform. I'm not writing on the board, you have to write and I'll see it. I'll check whether you have written it or not. Okay, don't think eternally we'll have online classes. And you have to come back here. So quality is waveform. So what kind of waveform? You see, different vibration, not even humans. If you are playing a piano, suppose you are playing Sare Jahan Se Acha in your piano, and some of your friend is playing 15th August maybe, like another friend of yours was playing the same tune in guitar. You'll understand. Why? Because guitar has a different type of vibration, the nature of vibration, the waveform. So similarly here, you have exactly everything similar. I am drawing this grid lines in order to produce that. Suppose we have a waveform like this. I don't know what instrument is this, whatever it is. And we have a waveform like this. Obviously, you see, they have same frequency, same amplitude, same type of vibration, same periodic nature, but they have different progressions. This is called the movement, the progressive wave, whatever it is, the sound wave, when it progresses through the medium, the nature of vibration, the waveform differs, and we can differ the quality or the timbre of the sound. Okay, so this is it. We have one more small topic, which is the characteristics of musical sound. Right now we were doing characteristics of sound, 3 characteristics: loudness, pitch, and quality. And in quality we have 2 things: noise and musical sound. And we'll understand what is musical sound just now. We'll see one picture more from quality, and then we'll do the musical sound, and we'll finish the this particular part. Okay. And here you can understand how different waveforms are formed in different instruments. The first one is showing you the tuning fork, and the second one is showing you the waveform of a piano. You can see they have mostly the same frequency, but the waveforms are different, and so the quality of sound emitted from a tuning fork and that of the piano is definitely different. And this is how we can actually distinguish the timbre of sound or the quality of sound, which I told you that waveform is the quantitative measure of quality or timbre of sound. Okay, so please go through these sections from your textbook, and now we'll do the basic characteristics of musical. So I have written the column. You should also write it in your classwork: loudness, pitch, and quality, and their corresponding quantitative analysis, intensity, frequency, and waveform. Okay, this is important. Please do write it in your classwork. Now we'll understand what is the characteristics of musical sound. Don't forget, these are the characteristics of sound. If it is the characteristics of sound only, then that is these 3. But if it is the characteristics of musical sound, then these are the points we have to write. What are these? Soothing to ear and regular. Waveform, which forms is regular and periodic and do not have sudden change in vibration. That means they do not have sudden change. Means in music we have changes. Definitely we are not going to play the same note for eternally. But what we do is we follow a logic, we follow a sargam or some staff reading in order to play the tune. So we have a logic, predefined logic by which we create music. So those things are not sudden, unlike noise. Okay, so I'll come up with a doubt clearing session in our AccentUs WhatsApp group. Till then, it's Arijit Ray from AccentUs, and please be safe and please stay productive. Thank you.